Hello everyone. So today we are talking about growth and decay. So we're going to investigate functions like y equals ax, y equals ax plus b, y equals ax, a raised to x plus c, and y equals k ax. So what we're looking at really here is exponential functions. So these are functions that are going to grow exponentially. We can also look into logarithms and the natural log. So here are some exponential functions that have been graphed. We've got h, f, and g. So as you can see, f and g are decreasing exponentially and h is increasing exponentially. So these are some functions a raised to e, bx plus c. So c is going to basically adjust the height here. So let's consider if x is equal to 0, then the value here would be a plus c. So you can see c is going to shift the whole graph up, but a is going to adjust the rate at which it's increasing. But the biggest thing which is going to increase the rate at which it's increasing is this b, because it's going to increase exponentially. So with a logarithm, basically what we're doing is we're saying we've got log ab equals x. What you're fundamentally asking yourself is we want to multiply this a by itself over and over and over again. And if we to get to b, how many times do we have to multiply over and over and over again? And that's the solution. So what you're saying is, let's say a was 2 and b was 6. You're saying how many times you need to multiply a by itself. 2 times 2 times 2, that's 3 times to get from 2 to 6. So x is going to be 3. So if log a, b equals x, then a raised to the x equals b. An example here is that log in base 10 of 100 is going to be 10. And generally we write log x, and this is shorthand for log base 10x. But you could also have log base 2x, log base 3. You can have any base, and that's the a value. And these are some examples right here. So here we have log base 2x, natural log x, we're going to talk about that later, and here we have log base a half x. So here are some laws to do with logarithms, some properties. We've got log w, wx equals w, log wx equals x. Yeah, I want you to write these laws down. They're all going to be useful to you. We've got the multiplication rule. So log w, y times x is the same as log base wy plus log base wz. Log base wy divided by z is the same as log base wy take log base wz. And log base wb raised to the x is equal to x log base wb. So this one's important. You're definitely going to be using this because this is probably the most important rule of logs. Because what this final rule allows you to do is actually go, and let's say we've got 5x equals 2, and you wanted to solve for x. Well, you can actually use this rule, take the log of both sides, and you're going to be able to get to a solution. So the rules we have here, we've got the product, the quotient, and the log of power rules. Please write them down, you're going to be using them. Here are some examples. So I'd really like you to have a crack of these. So consider the first one. Consider a bacteria doubles every hour. How many bacteria are there after a day? So bacteria, we have the equation, bacteria equals 2 raised to the 24, because there are 24 hours in a day. Well, therefore, bacteria equals 1,000 equals this number, 1677216. You can just chuck that in your calculator. So this is an equation using exponentials, right? Easy. Okay. How long until there are 1 billion bacteria? Here we have a more complicated question. So we've got this number, 1,000,000,000,000. So that's 9 zeros. So we have 1 trillion. So we have 1 billion. equals 2t. So 2t is an exponential. We've got a function that's increasing exponentially. But we want to solve for t. So we're going to have to use the power rule. This is, like I said, this is the most important logarithm rule. So we have 2 log t equals log 1 billion. Now we can divide by log 2, and we can just chuck this in the calculator. So we found that it will take approximately 30 hours to reach 1 billion bacteria. Now, this is very important. We're going to talk about the natural logarithm. This is the most important logarithm because e is a very special number. And when we get to calculus, you are going to figure out why e is important. But for now, we're just going to teach you that log of base e x is equal to ln x. So we've just simplified this term, log base e x, and we're just calling it ln x because you're going to use this a lot. Because when it comes to calculus, we like to put everything in terms of e. So the reason that this has its own word is just because you're going to use e whenever possible. Whenever you have a number such as 2 raised to the power of t, or 5 raised to the power of x, whatever, you could rewrite that as e raised to the power of some number, a, multiplied by x, or t in the initial case. All right, and yeah, thanks for watching. This was just a short one. We're going to get cracking with statistics next. And then it's calculus, and that would be a wrap for the methods course. Thanks for watching. See you next time.